do you watch per day? Go ahead and turn to this. It's your 5th lesson. What I would like you to do is I'd like you to try to fill this out as much as you can before watching my video that has the answers, or the part that has the answers. So I'm going to have you go through this as a lesson. A random sample of 30 students involved or revealed that the mean viewing time of X bar equals 25.3 minutes with a standard deviation of 14.8 minutes. Construct and interpret a 95% confidence interval to estimate the true mean daily YouTube viewing times for all students. Okay, so first of all, what is your point estimate? And so the point estimate is what we are estimating, and that is this right here, the 25.3. All right. Identify what's the population. So what are we, what's the sample? I'm going to start with the sample because it's the most obvious. A random sample of 30 students, right? It says it right there. And then the sample comes from the population. So a random sample of 30 students. And so where did the population come from? So go ahead and try to fill that out. And the parameter is, again, the statistic is easier to fill out first, and then you could do the parameter. So the statistic here is obviously this part here, the 25.3 minutes, and the parameter is the actual truth of the population. All right, is it a random sample? And why is that important? Let me give you a second to think about it. Now, what does a random sample do? I've demonstrated in class before that if I just pick the first people that are in front of me, or that maybe that are friends, or the first that come to the classroom, might have a different opinion than the entire class. And a random sample picks a little bit of everybody and is a good representation of the entire population. So that's why. So would it be appropriate to just do a normal distribution of the sampling model? Well, you have to see, the problem is we don't know the true standard deviation, so we have to use this here, which is the S, which is the sample standard deviation right here. And that means the sample standard deviation, remember to get the standard deviation with the sampling distribution, is making sure that you use your sample size of 30. So you're going to make sure you, let me go ahead and go to the formulas now. So you're going to use your 14.8 divided by the square root of 30, because that's the formula. If you go back to your unit 7, the very last day, we had all of the formulas listed, and that was one of the formulas. So let me show you here. So this is what you should have so far, is that 25.3 is the average that we talked about. All students is the population, and the 30 students selected from the all students. The parameters, the true mean daily viewing for all YouTube, and the statistic was the X bar is 25.3. We saw it's a random condition because it is given to us as random, but we can generalize our results to the entire population because it's a good representation of the sample. And we see it's a large sample because it's going to be, it says 40 is bigger than 30. That's a mistake. It's 30. Obviously, you see the 30. It's a 30 is greater than 30. Obviously, it's the same as 30, so that's the size that we need. All right, and then for the standard deviation I just talked about was here, 14.8 divided by square root of 30, and so my standard deviation is 2.7. This is because I'm doing a sampling distribution. So this is like, remember when I asked you to pick 5 NBA players and find their average height, and we had 30 people in the class, all picked 5. And so each one of you, the N in that case would be 5. This time the N is 30. So if I had 100 people pick 30 students, the N would be 30. It's how big your sample is, not how many trials you did or how many people did that. It's how big your sample is. Okay, so now when finding the margin of error, remember we used Z star. Now we're using something called T star. And the whole idea of T star is because I don't know my normal model, so I have something called the T distribution, and it looks really, really, really similar to the normal distribution. If you're on your table, instead of the table that's in our little formula chart, the white one, that's the Z chart, now you're going to use the T chart, and it's kind of like a pale yellow color. And you can see that the formula now changes to x bar minus mean, which is mu, over s divided by square root of n. And you can see that the model is still unimodal and symmetric. It's just shorter and flatter. The degrees of freedom is n minus 1. And what that means is if I tell you I have 3 numbers that I want you to choose from, and I want them to total up to 100. And let's say the first person says 30 and the second person says 60. So 30 plus 60 is 90. The third person has to say 10 because I told you the 3 numbers have to measure up to or add up to 100. So that means only 2 of the people had the freedom to choose what they wanted, and the third person was absolutely forced to do that number 10. So the degrees of freedom that you have in here is the size of your sample minus 1 because of our curve the way we have it. All right, to do T star, you're going to do the same thing that we did for Z star, except instead of inverse norm, it's going to be inverse T. So for this instance, this one here, it asked me to find a T star, and let's see, the T star for my standard deviation, let's see, what's saying 90, sorry, I lost it here. I think it said 95, yes, 95%. So remember, we're going to be using the center part, the 95% plus the tail. And so there's 2.5% on the tail. So go ahead and grab your calculator and do this along with me, please. And instead of inverse norm, you're going to go to menu, stat, distribution, and you're going to go to inverse T. So for inverse T, you're going to put 0.975. And remember, degrees of freedom is the size of the sample minus 1. So we're going to put, it was 30 minus 1, so it's 29. And that's where the 2.045 comes from. You can do 2 or 3 decimals. Either one is completely appropriate. But if I'm asking for the margin of error, it's just T star times my standard deviation over the square root of n. And then number 5 is when I found the standard deviation of the square root of n, so I got 2.7. So finding the 95% confidence interval is going to be my point estimate plus or minus my margin of error. Remember, that's what it always is, point estimate plus or minus margin of error. On our previous lesson, we had proportion, and I'll review that again with you. So we are 95% confident that the interval from 19.78 to 30.82 minutes captures the true mean of the daily viewing for all students. Okay, so the 3 things that you need to make sure you write down, we have our conditions still, we have data needs to come from a random sample, and I need a normal or a large sample. And so now I don't have any proportion, so my sample size needs to be bigger than 30 or equal to 30. Now, you guys saw the critical values that we did. The Z star is when I use inverse norm. You might want to put it next to proportions. And the T star, I use inverse T. The degrees of freedom is n minus 1. You can use, if you use the table, which I'll show you how to use the table, but you use degrees of freedom. If it's not listed, you just go to the one below it because it means it's doing a smaller sample is more conservative. Because on the table, you'll see that it's not all listed. So, and then here, it's just the formula for confidence interval is just the point estimate, which is your mean, plus or minus your margin of error, which is for this one, T star times S over square root of n. Okay, so go ahead and do this. If we check for our random conditions, let's look at it. For their second semester project, Anne and Tori wanted to estimate the average weight of an Oreo cookie to determine the average weight. If it was less than what it advertised, they selected a random sample of 36 cookies and found that the average weight was 11.3921 and the standard deviation was 0.017 grams. Okay, so the confidence interval. So it says check the conditions. So was it random? And was the sample large enough? And we do see definitely it was random because it stated it was a random sample, and the sample was 36, and that's bigger than 30. So notice I don't have NP, NQ, or NP and 1 minus P because there's no P, there's no proportion. P stands for proportion. For means, there's no proportion, so we just have to see if the sample size is large enough. Okay, the next one asks to do the confidence interval. Remember, to do a confidence interval, it's going to be the point estimate plus or minus the margin of error. So it's going to be, first of all, I have to find 95% confident for degrees of freedom of 35. So you're going to go over here, and you're going to go menu, stat, distribution. Go ahead and please do this with me so you can make sure you know how to do it. And pause the video if you need to. And inverse T. and it's a 95% confidence, so it's the 95% plus the 2.5% tail. The size was 36, and so I need to do 1 minus that, and so it's 35, so it's 2.03. 2. Oh, did I use? Oh, okay. So they use, the reason their T-star is a little different is because they use the chart. On the chart, there is no 35, so you have to go, the closest one on the chart they have is 30. So that's why theirs is 2.042. So their answer is going to look a little different than ours, but you can use this number here that I used here, which is 2.03. So it's going to be our X bar. It gave me this here at 11.3921 plus or minus. They have 2.042. Remember, we have 2.032 because we did ours on the calculator, not on the chart. And the standard deviation, which was given to us, was 0.0817 divided by square root of 36. Okay, on the packaging stated serving size 3 cookies, does the interval of in question 2 provide convincing evidence that the average weight of an Oreo cookie is less than advertised? And no, because all of the values of the mean are greater than 11.33, because we're saying for 3 cookies. And that's not convincing evidence, because you can see I got between 11.36 and 11.41, and we're at 11.33, so my whole interval is way higher than that. So no, I don't have convincing evidence. So that's it, and I hope this helped, and we'll see you next time. Go ahead and make sure you upload it if you haven't already.